Ladies and gentlemen, let's say we have another vector, all right? And again, it's going to be a component form of a vector. Okay? And let's say it's right down here. Okay? Now, if I have the component form of this vector, and let's say I want to double the length, double the magnitude, all right? That means instead of having my points v1, v2, I want to now have them doubled. Now I want this to now I want that point to go all the way out there. How is there going to be a way that I'm going to be able to represent for this now vector to be out this way? So right now, this is vector v. So how am I going to want to describe double that amount? Well, what we're going to do is we're going to use a scalar. All right? And scalars are very common, just like we've used in other mathematics. And the way that the scalar is going to work is, let's say I have a scalar k. So if I multiply by a scalar k, any number that's larger than 1 is going to increase the size of your magnitude of your vector. Right? If k is equal to 1, your vector just remains the same, right? Or your magnitude remains the same. Think about if my magnitude of this is 5. If I multiply by 1, the magnitude is still 5, right? If k equals 2, if k equals 2, my new magnitude would be 10, right? So how do we know, though, what the new points are if I use a scalar?
Wait, where is k represented, please?
Huh?
So it's v and then k?
Well, what I'm saying is, no, it's k times v.
Well, no, I'm talking about the line.
This is going to be,
Is the blue one k? Oh, no.
this is kv. What I'm doing, I've just increased this. I've doubled it. So this whole new vector is my scalar times v. Okay?
So in this case, it's 2 times v.
It looks like it's around 2, right? Yeah. I haven't used any numbers yet. But yeah, you could probably estimate that k is equal to 2. All I want you guys to understand is if I use a scalar, right? If I go ahead and use a scalar, you guys need to know that that scalar gets multiplied by both components of your vector. And therefore, you're going to have a new one. Okay? So let's just go through a quick example. Let's say I say v equals -3, comma 2. Right? So I go -3, 1, 2, 3, up 2. Right? And then let's say I'm going to say find find 3v. Okay, so that's your new scalar, right? So it says find 3v. So now what I'm going to do is I'm just going to say, well, that equals 3 times -3, comma 2, which equals -3 times -3, comma 3 times 2, which equals +9, 6. So now, why did I multiply? I put in positive in there. You're right. That doesn't make sense. So now I go over -9, 1, 2, 3, 4, 5, 6, 7, 8, 9, up 6. 1, 2, 3, 4, 5, 6.
So we use Robbie for the next.
You will be asked, yeah, to sketch the graph, sketch what it's going to look like. All right? And then, so the important thing, guys, if k is greater than 1, right, the absolute value of k is greater than 1, that's going to increase your magnitude. I'll just call it like this. Right? So then what do you think if k, the absolute value of k, is now less than 1? What if I said 1/2 of this vector? What do you think it's going to do? It's just going to shrink it, right? So that's going to decrease the magnitude of v. But the same thing applies, guys. Whatever it is, I don't care if it's 2/3 or if it's 7,000. You multiply it by each term. Okay? Anybody have any questions on that?